So we've already talked about using the print writer and the scanner for doing text-based file I/O. Now we're going to talk about object-based file I/O, which is where you write out an entire object at one time. And whether those objects are just individual little things like, wrapper classes, double and integer, that kind of negates the power of doing it. It's when you write out a large object of your own creation that is really useful, because then you can do it just with a single call. You want to write out your car class, you do it once. You want to write out your, read in another car, you can do it that way. So the way we do that is to use Object File I/O. Now here's what they say. In object-oriented programming, most data is in the object format. And the structure of objects is user specified. There's no universal format for storing objects and files. This is very true, because once you do this, if you make your output do this, then you're not going to then be able to open the file in another language like Python or C++ and have it easily read back in. They both do their own things. Whereas if you save it as a text file or a data file, then you have a good chance of being able to make them cross-compatible. But anyways, we're doing Java. Each object's variables must be stored separately using a format that is appropriate for that type of object. So you have an employee class, you write out their name, you write out their birth date, you write out, their address, each piece by piece. We can automate this process with Java's serialization service. Service is not the correct word here. Interface. To get the service, you create your class, but then you do implements serializable. We did talk about interfaces, did we not? Please tell me we talked about interfaces.
Yeah, it's like an abstract
It is.
class.
It's like an abstract class, but right. But you can implement several of them.
Yeah.
Right. Okay. Yeah. Cool. Okay. And then the Java virtual machine handles all the details. So we could look up the serializable class and see what it actually gives us. But essentially, it gives us the ability to convert that object into a set of data that could then be written out or read in. Serialization of a class is enabled by implementing the java.io.serializable interface. The simplest version of implementing it is just to put the words implements interface. Classes that do not implement this interface will not have their state serialized or deserialized. When you're trying to write it to a file or send it down a socket, to another machine. Once you do that, then you get classes that can throw exceptions, but which you can use your object. You can write the object out. You can read the object in. If you need to, you can customize the serialization and the deserialization by overriding the special methods with these same exact signatures. Now, we're not going to cover that. We're just going to let the Java virtual machine handle. Now, so this is getting way more technical than what we really need to know. We're going to go back here. So what you do is you use the object output stream and the file output stream classes in order to get this work. And then you do fileout.writeObject, and boom, you're done. You've written your entire object out. Then when you want, you can read in the object. Same thing. You create a file input stream, do an object input stream, and you're good to go. Reads it in one fell swoop. Test object is you have to cast its result from the read object method stored into your new object, and you can do something with it. So to play with this, we're going to create a really silly, dummy little class. Same kind of thing we've been doing. Our breed and our name and our animal's age. How about that? So let's make a new project. I'm going to call ours mine object IO demo. I'm going to tell it not to use a package by deleting everything in front of the period, so it just says object IO demo there under create main class. You can always just delete the package statement and fix it. And of course, we're going to have a whole bunch of file imports that we need to do. But let's create our class first. I'm going to try to be a good boy and put the class in its own file. So I'm going to come over here, default package, or wherever your ObjectIO demo file is. Right-click, new, Java class, Animal. So, string name, string species, string breed, that's enough. It'll show the point. Boolean. I'm going to go ahead and put age in, although that's really stupid, right? You just really want to do their age. How about last weight? So double weight. Just to show that we're able to read in both the strings and the numbers all at the same time. Now, if we're good programmers, we'll add getters and setters for everything to do some encapsulation. I'm going to totally cheat. Highlight those 4 lines, go to Refactor, Encapsulate Fields, and just let it do it for me. Good enough. I don't even know why I'm bothering to delete the comments. Those comments are actually useful if you're using something that will display them. Whatever. I'm going to stop doing that. Okay, so there's my animal. What I do want to do is bring the variables, instance variables, back up to the top, because I like seeing those underneath the class name. All right, so there's our class. And we added getters and setters for them all. So let's create an animal. Let's actually ask the user what they want to do. Nah, let's not. So animal A1 is equal to new animal. A1.setName Fluffy. A1.setSpecies is cat. A1.setBreed Persian. A1.setWeight equals 10. That didn't seem to work. Why did I do that? Not equals 10. SetWeight parentheses 10. Now we have an object. Try not to fluff this up too much. But we're going to need a file output stream and an object output stream. So to save myself a little bit of time, I'm just going to come and add and import java.io.asterisk up to the top. So import java.lowercase io.star. That should get me all the classes I need to do this file IO. And what am I doing? I want to write something that will open the object output stream, which I'm going to now abbreviate OOS, write our object to the OOS, then close the object output stream. And if we wanted to, we could write out a whole bunch of objects in a row. Then we're going to open the object input stream, write the object to the object input stream, and close the object input stream. And I kind of wish that I had made this, in a menu-based program. Tell you what, we will do that just a little bit. No, we won't. We're just going to put it straight code, make it at least complex. Okay, so file F is equal to new file. We should ask for a file name, right? I'm just going to hard code a string right now. String file name is equal to animals dot. Now it's not going to be a text file, but I'm going to call it .txt anyway, so I can just double click on it with Notepad or whatever, and we can see that it's not going to be text. Now, you could call it .bin or .dat for data, something like that. Anyways, file f is equal to new file, file name. We're going to have to put all this stuff in try-catches. File output stream is equal to new file output stream parentheses f. I forgot to give it a name. So FOS for file output stream. And then object output stream OOS is equal to new object output stream, passing in FOS to the constructor. Now it's complaining unreported exceptions. We need a FileNotFound exception, and we need an IO exception. So try all this stuff. Catch FileNotFound exception. System.out.println could not open space end quote plus file name close parentheses semicolon, and then the IO exception. Catch IO exception. System.out.println IO error writing space end quote plus file name. Now we haven't closed the file yet. We haven't written to it, have we? We have our file, excuse me, our animal. It was called A1. So here we're going to do object output stream dot write, and notice all the different options we have. We could be writing these things individually. We could write a double, a float, an int along. Notice that these are all wrapper classes. So you could write your code so that it writes all the pieces out individually, which is better than a text file in some ways. At least when you read them back in, the conversion happens automatically, whereas if it's a text file, you have to do the conversion yourself, parsing it. But anyways, we want OOS.write, the generic version, object, and pass in our animal. And then let's close our file. Now I'm wishing I made a few changes here. I wish I had declared my variables outside of the try block so that I would still have them hanging around, so that if I wanted to throw my close in after all this stuff, I could do that. But I didn't, so I'm going to, maybe I'll change my mind here. Object output stream.close, file output stream.close. Is it necessary to do both of them? Not really. Our example here does not show us closing the file output stream. It just closes the object output stream. I guess I will follow their example and only close the object output stream. Let's go back and look at what they did differently than what we did. They used anonymous objects. They did new output stream, and inside the argument for object output stream for the constructor, they did new file output stream, and they just pass a file name there rather than a file object. I'm kind of weird. I like doing the file, then the file output stream, and then the object output stream, and I like having all of those available to us. Tell you what, let's move them up there. So above try, file f equals null, file output stream equals null. Can I type? File output stream is equal to null. Object output stream equals null. And then I need to remove the data types from inside my try block. So instead of file f, it's just going to be, I forgot to give these names. File output stream FOS, I'm being sloppy, is equal to null. Object output stream OOS is equal to null. Then correct my code down here, remove the word file output stream, remove the word object output stream. I just think that's useful information to be able to play with if I'm going to enclose more than one try-catch block. Because if once I put all this stuff inside a try block, that's pretty much all she wrote. I can't access it from within another block of code. It pretty much means that I have to put everything right here. Maybe I don't. Maybe I want to open it in one part of the code and then write the object out in another and then close it in a third. I'm going to leave that as is, though. This ought to be enough to get it to work. But let's put a print statement just saying that it worked. Right? So after we do oos.close, system.out.println, wrote object to file. And you get a couple of warnings, say the assigned value is never used, but that's not strictly true. We could, I mean, it is, but we could go back later and restructure it so that we check, closed the file in a different try block, for example, and then suddenly it would be used. So I don't mind leaving those equal nulls there. I think that's useful information that we could potentially use as we restructure the code, so I'm going to leave it. All right, let's hammer and broom it, run it, green arrow. And it said IO error writing animals.txt. Well, I wonder what the error was. That is so generic. So I'm going to come down here and just print out the exception itself. System.out.println. I put this in the catch IO exception.ex. Println ex.get message. Oh, I know what the error is. The error is we did not modify our class to implement the serializable interface. And so once we run it, we should get an error to that effect. No. But that is the problem. Our real problem here is that IO exception. If you catch IO exception.ex, this is a generic catch. And so we're not getting a specific error. I'm going to try commenting all of this out. Excuse me. And now all of a sudden it's giving us places where write object, well, it's still just telling us IO exception, but that's not really what it's throwing. If we come and we look at write object and we view the Java doc for it, we will see that it throws some specific exceptions. Invalid class exception. Something is wrong with the class. Not serializable exception. That's actually the problem, is that our class is not serializable. So, to be more correct, we should add catchers for these as well. I think I'm going to go ahead and do this one, just because I want to prove that that's the problem. So I'm going to come back in, and underneath FileNotFound or whatever, I should just cut and paste these. Catch oh, come on. All right, back to where I was. Catch not serializable exception. EX. system.out.println class not serializable. Is a user going to want to see that error? No way, but it's of interest to us. And I commented these things out, so I'm going to uncomment them. Now when I run them, the class still isn't serializable, and that's why we get that exception. But that's well and good, because that's what we need to change.
For some odd reason, mine says that it has already been caught, the non-serializable exception.
Yeah, if it says that this exception has already been caught, it's because you put it underneath IO exception. IO exception is a superclass to not serializable exception, so it'll catch that one, and then any subclasses of it cannot be caught. Just kind of like if you do catch exception.
Okay.
You better put that catch-all at the very end. Okay, so we need to make the class serializable. We go over to our animal class, and we do public class animal implements serializable. It doesn't know what the serializable class is, so I'm going to add an import for it, java.io.serializable. Tell you what, I'm just going to come up and do import java.io.asterisk. Make that go away. Now we didn't need to add the getters and the setters for serializable to work. With that done, save that one, go back, save ObjectOI demo again, run it, and it says wrote object to file. Let's go see if we can find that object. What directory is all this stuff in? Documents, My Documents, NetBeans projects, ObjectIO demo. There's my text file, animals.txt. So if I open it up, okay, I see something that says animal, and I see something that says wait and breed. SR might mean string. We don't really know what any of this stuff means, right? And then at the end of it, java.lang.string. And then we get the actual object data. It's a cat. Its name is Fluffy. It's a Persian. Who knows where that number is stored? It's stored in a binary format, so we're not going to see it as a text format because binary and text are not the same. So that's what our object file looks like. You know, you can open it up with a hexadecimal editor to get a better look at it, but really, we're not going to be able to open this and parse it individually, or it would take a lot of effort to do that. So we would just trust a serializable class. What are the drawbacks of using a serializable class? If you go and you change the class, you go and add a new member, you know, a new data member to it, then it's no longer compatible with all the objects you've already written out. So it's not the best thing for that to happen. If you
add a new instance variable.
Right. So I got an animal written out, but then I decide that all of my animals also need to have a birth date, and I go and I add that instance variable. If I write some code that's going to read it in, it's going to crash because it doesn't. Well, it's going to throw an exception because it doesn't know how to fill in that new piece of data. It's invalid version. You have like a version 2.0 of your class, and you can't read the version 1 into it. So if you are worried about that kind of thing, this is not the best way to do it. But if you have control over what's reading and what's writing, for example, you're sending this data down a socket or whatever, then you can make your server and your client require them to be on the same version, you know, else it's not going to work, you know, for these objects to be sent down the wire that way. Okay, we've got all this stuff. Why don't we open the file back and read it in? So we already had file F, right, for writing to a file.
Yeah, we defined it out of the try block, so yep.
I think I'm going to give myself a new one. File if is equal to null. And then FIS for file input stream.
I don't know if you can use file IF.
Oh, you're right. That is really bad. Okay, fine. I'm just going to use f is equal to null. But I'm going to note what it is. F is a file. Is of type file. Okay. And it's not file FIF, it's file input stream. FIS. Don't capitalize the T in stream. Don't be like me. Object input stream. OIS is equal to null. Now we're going to try some stuff. Let's open our file for reading. F is equal to new file, file name.
Yeah, I don't know why. For some odd reason, mine is saying cannot find symbol for file name, even though it's defined outside of every. Oh, never mind. I say what I did. Never mind. I accidentally put it outside of main.
Oh yeah. If you put your variables outside of main, well, it ought to work, but you have to make them static. Okay. So back down here, we have our file. Now let's create our input stream. FIS is equal to new file input stream using our file. And then OIS is equal to new object input stream FIS. And it's yelling at me because I don't have the proper catches. This one can throw FileNotFound. This one can throw IO exception. Tell you what, why don't we just go and copy our catches from the other code? We may have to add something else, but I'm going to come up here, and we had several exceptions after our first try block, the FileNotFound. I'm going to copy that one, the not serializable, and the IO exception. So we only had 3 exceptions I need to copy. I'm just going to highlight all that stuff, Control-C, or however you like to copy. Come down here, and after my try block, I'm going to catch all that stuff. All right, so that's what I have now. Except, IO exception should say IO error reading file name. Alrighty. Now we need to read our object in. Let's make a new animal. I'd like to declare this animal outside of the try block too. So, above the try, animal A2, but I'm just going to set it equal to null. And then A2 is equal to it, and what we read in had better be cast to an animal because it's just an object. A2 is equal to the animal version of OIS.readObject. Class not found exception must also be caught. All right, we'll have another exception that we need to add. All right, and then OIS.close. Now the problem with the way we've structured the code here is really we're just writing one object and we're leaving and it's blasting over the file, or we're opening the file and we're reading one object. It doesn't let us write out a series of objects. But we can fix that too. So what was our new exception? We have to add class not found exception for read object. So underneath my try, catch, parentheses, class not found ex system.out.println error reading plus file name plus semicolon class not found. Yeah, like the user wants to see that. But there we go. I forgot the word exception. Catch class not found exception space ex. Now, we didn't print out that we read it or anything. So let's add a print message here saying that we successfully read from the file. So underneath ois.close, system.out.println read OK from, or read successful from, plus file name. That other one ought to say write OK from file name, or data read from. We're not reading, yeah, we are. So data read from file name.
So if we were to go back now and add a new instance member, it would be all messed up.
The reading of that object would be all messed up. Our code would still work because it's writing. Yeah, the question is, if we added a new instance member, would it all be messed up? And as far as our code is concerned, no, it would work. But the only reason it would work is because we're writing the object right before we read from it. So they're both of compatible versions. If we went out and we wrote the data and we made this a menu-based program, changed the data format, then tried to read in that old obsolete object file, then it would be a problem. Okay, I want to see that message come up saying that it read, data read from. Okay, so let's write out our object. And yeah, we could go, what I mean by write out, let's print it out. We could go and add, a toString method and stuff like that. But we better make sure that we have a valid object. If I keep scrolling up and down, sorry about that. But if we don't get to this line of data, or if this does not succeed successfully, then our animal object A2 is null, and we can check for that. So I'm going to scroll down here, and I'm going to say if A2 not equal to null, it means we have a good object. System.out.printf name %s species %s breed %s weight %f because it's a double, and then a \n. Excuse me for formatting this a little bit different. I'm going to put this format string on its own line. After the \n end quote, I'm putting a comma so that I can fill in my animal data. A2 dot get name, parentheses in parentheses, comma, A2 dot get species, parentheses in parentheses, comma, A2 dot get breed, parentheses in parentheses, comma, A2 dot get weight, parentheses in parentheses, one final close parentheses and a semicolon. And in case we get here and object is equal to null, we better warn them, you know, or at least as far as our code is concerned here. Else system.out.printf, read failed, no data to display. So when we compile and run it, we should see our Fluffy the cat information show up. All right, Fluffy, species cat, breed Persian. Now what if you have more than one piece of data? Well, you could just write them all out, or you can store them in one by one by one, you know, you could have a loop, or you could store them all in an array list and write that array list out. Then when you're ready to read it back in, you could read it in as an array list. So we're going to do that. Array list. I don't want to call it animals, but AnimalList. Hate making them so long. Is equal to new array list, square brace, animal, int, not square brace, angle bracket, animal, greater than sign, parentheses, in parentheses, semicolon. It's going to complain, so we have to import java.util.ArrayList. Now this class already is serializable, so it will serve our purpose perfectly. Let's add a couple animals to it. We're going to need to make a few more. Animal D1 for dog is equal to new animal. We should have put a constructor there, right? D1.setName Fido. D1.setBreed.
You just want to go make a constructor?
Yes.
Let's make a constructor, guys. Yeah. Alrighty. So go back to the animal class. Public animal parentheses string name string species string breed double weight into parentheses open curly brace. Inside there, this dot name equals name. This dot species is equal to species. This dot breed is equal to breed. This dot weight is equal to weight. And while we're here, let's go ahead and make a toString. Public string toString. Return this dot name plus a space plus this dot species plus a space plus this dot breed plus a space plus this dot weight. Is this the world's best formatting? No, but it'll work. It wants the @ override tag, so @ sign, capital O, override. Not necessary, of course. Just helps the compiler prove that we really did override it successfully. Alright, so what did we add? We added a constructor and a toString. Alright, I'm going to go back to ObjectIO demo, and we're going to create some dogs. Animal D1 is equal to new animal Fido Who's this? Why is my brain going totally blank? Doberman. Who's a dog? I should have reversed the order of those, shouldn't I? And who weighs? Dobermans are heavy. I don't know how heavy they really are. Animal D2 is equal to new animal. Goofy, who's a Great Dane. It's also a dog. Who weighs 120. They don't all have to be dogs. Animal D3 is equal to new animal Harvey, the Wonder Hamster. So Harvey, who's a hamster. Hamsters are rodents, I hope. And weighs 0.1 pounds. Let's add all three of those to our array list. So AnimalList with capital L dot append D1. That didn't work. What did I do wrong? Is it just add? Yeah, add D1. Do the same thing for D2 and D3. AnimalList dot add D2. AnimalList dot add D3. Now, why don't we pretend that we care enough about this to modularize it just a little bit? We're going to write a function called WriteAnimals to file, and we're going to pass in a file name, animals.txt. Yes, I should store that in another variable. But let's make sure it worked okay. Boolean write OK is equal to WriteAnimals to file. We're going to have to write that function. If write OK system.out.println animals written to file. It's bugging me not to have put that thing in its own variable, so I'm going to cut that, put the file name there, and so file name is equal to quote animals.txt. Else system.out.println could not write to file plus file name plus quote semicolon program exiting. And let's just return. Is that a cool way to do it? No, we ought to loop and ask for a new file name or let them correct the error or something like that. But anyways, okay. If we get this far, hopefully it means that we can continue. So Boolean read OK is equal to read animals from file name. And if read OK, we want to print all the animals out. So system.out.println animals read from file, and let's just have a for loop that reads them all, that prints them all. For animal A colon animal list system.out.println good enough. Or animal colon space plus a. Seems like I'm getting an error here. What have I done wrong? Object cannot be converted to animal. Yeah, I did this wrong. I did this totally wrong. Well, not totally wrong. I'm not sure why that's not working, but ReadAnimals from file is actually going to have to return a new animal list. So I've kind of botched this one. I'm not going to make it read OK. Instead, it's going to be ArrayList angle animal new data, new animals is equal to ReadAnimals from file, parentheses file name. And we're going to write our function so that if it fails, then new animals is going to be equal to null. So if new animals not equal to null, then system.out.println animals read from file. And we're going to have to pull our animals out as objects. Is that true? For every animal A in new animals. Well, that seemed to work. I don't know what our malfunction was before that. Okay. So that's good enough. What's left is the hard part. We have to write a ReadAnimals from file method, and we have to write a WriteAnimals to file method. I'm debating whether to let NetBeans fill in some of this stuff or not. I'm going to go ahead and let NetBeans fill in one of these methods, and then we're going to do the other one by hand. See the red error? Come over here. And it says create method. I'm going to go ahead and do that, but then I have to go and find that. So I'm going to right click on WriteAnimals to file and do navigate to declaration, and there we go. Why did I do that? Well, it saved me from typing private static boolean function name. But all it does is throw an error, but that's not good. Yeah. So anyways, we got to fix this. We don't have any data, though. How can we write our animals to file without any data? We need to have an array list that we could also. So WriteAnimals to file is going to have two parameters: string file name, comma, array list, angle brace, animal, end angle. I'm just going to call it a list. Now we have to do all the same stuff that we did earlier, but I'm going to try to speed it up as much as possible. So try this stuff. File F is equal to new file, parentheses file name, capital F on the new file. File output stream FOS is equal to new file output stream F into parentheses. File input, no, object output stream OOS is equal to new object output stream FOS. And let's write our stuff out. OOS.WriteObject, and we're going to write out the entire array list in one fell swoop. So OOS.WriteObject a list, and then close OOS. OOS.close. And if we get that far, it all worked great, so let's return true. Now we have a whole bunch of things that it wants us to catch, most specifically FileNotFound and IO exception. So we may as well add our catches. Catch file not found exception ex system.out.println could not open in quotes, space, in quote, plus file name plus a space for reading, end quote, in parentheses, semicolon. We have other ones to catch. I think I'm only going to catch IO exception rather than that sequence serialized error. Although we should catch class not serializable ex.
We're going to need the exception.
Class not serializable exception ex. Yeah, I've goofed on that one. Let me go find out what the error really is. Not serializable. Okay. Going back to where we were. It's not class not serializable, it's just not serializable exception. System.out.println error reading file, end quote, plus file name plus space, or plus quote, semicolon, class not serializable. Again, if we were writing this for users, we'd come up with better error messages. They don't need to panic over that, but maybe just print out an error code that they can look up. How's that for useful? I don't know. Hopefully they're not going to see these errors. Hopefully they would not get something as nitty-gritty as a class not serializable. But if it's a possibility, you need to communicate to them that, incompatible versions or something like that. And the last one was IO exception. Catch parentheses IO exception ex. Print that out. I should be copying and pasting my print errors. So I'm going to copy system.out.println could not open file name, Control C, come down here, Control V it. This should not be error reading. This is an error. This is a writing. Isn't all of this writing? Because aren't we inside WriteAnimals to file? Okay, everywhere I said the word reading, change that to writing. Could not open file name for writing. Error writing file. And then lastly down here, could not open, or how about just IO error writing to plus file name in parentheses semicolon. Now we have that method. We have typed an awful lot. I would like to be able to go ahead and run this and have it work. But unfortunately, we still have a few problems. Specifically, what's this do? Oh, what's wrong with this line? Now that we've changed WriteAnimals to file, what was the big change that we made to it? We added a second parameter, which was the AnimalList, second argument. So where it says Boolean write OK equals WriteAnimals to file, scroll down if you need to find it, or double click on the red arrow where however you find it. After file name, put comma AnimalList. And we had one more method, ReadAnimals from file. So I'm going to scroll down here, find a good place for it. private static ArrayList, capital A animal, read animals from file, and then inside our argument list we just need a file name, string file name. Same business we did earlier. We need a try and a catch. File F equals new file with the file name, lowercase file name. FIS for input. Nope. File input string, FIS is equal to new file input string, passing in that file name. Object input string, OIS is equal to new object input string, parentheses file name. No, not file name. FIS, right? File name is being passed into the file output in file input stream, and then the file input stream is being passed into the object input stream. Assuming we get this far, hopefully we can actually read it. So we need to declare a new animal array list. So array list, parentheses, animal, a list. A list is equal to OIS.readObject, but that's not going to work. We're going to have to cast it. That's annoying, but we got to. So A list is equal to parentheses array list angle animal end angle end parentheses. And if we got that far, great. So return our A list.
Do you have to do that on two separate lines?
That did not have to be on two separate lines. That could have all been on one line.
Do I still have to?
Do you still have to cast it? Yes. The reason you have to cast it is everything on this side of the equal sign happens first. So it doesn't have any information about what it's storing or what it's reading. Because as far as this is concerned, all of this happens before. It doesn't even know anything about this thing in front of the equal sign. So yes, you do have to cast it. Okay. But we have our exceptions to catch. Why don't we just copy our exceptions from the other code? Wherever they went. Find your code with the exceptions. Here's my WriteAnimals 2 file. I'm just going to copy all those exceptions, and I'm going to change the word write to read on them. So FileNotFound, not serializable, IO exception. I'm going to copy all of those from the WriteAnimals to file, and I'm going to go and paste those into my ReadAnimals from file. And I have a problem with WriteAnimals to file. I forgot to make it return a false. But anyways, so after our try block inside ReadAnimals from file, paste all of our exceptions, change all the could not open for writing stuff to could not open for reading, error reading file, IO error reading from. And so why do we need a final return? Because it's trying to return an array list. But if we get here, that means we don't have an array list, so we just better return null. Same for the other one. We returned true if we wrote the data out, but we're not returning anything if there was a problem. So this was at the end of ReadAnimals from file. At the end of WriteAnimals to file, I need to go and put a return false. Now it's still complaining that we have an error somewhere. Unreported exception, class not found. I forgot. I wonder why. Okay, anyways. That was the other error that we have to catch. So, scroll back. Well, just click on the little red error message. But anyways, inside read animals from file, there's one more exception that we did not handle. And we had to do this the last time too. Catch. Now I've already forgotten what the exception was. Class not found exception. So catch, parentheses, class not found exception, ex, system.out.println. Class not found, error, reading, space, plus sign, file name, in parentheses, semicolon. Alright, it's still complaining I have an error. Constructor animal and animal class cannot be applied to given types. I have a problem, which is that when I added a constructor, remember when we did that? We broke our code. And why is that? We added a customized constructor to our animal class and it broke our...
Is that because we have an animal declared but we didn't use the constructor?
Once you create a custom constructor, a parameterized constructor, your default constructor is no longer provided by the compiler. So we have to go back to the animal class and add one more constructor, which is the default constructor. Public animal, parentheses in parentheses, and it doesn't even have to do anything. So curly brace, close curly brace. Default constructor. So anytime you add a custom constructor, if it's an existing code base that didn't have one before, and you want it to continue working without change, you better add the default constructor as well. Alrighty, I hope you were all able to follow along with that. Let's run it. I'm pretty sure it's going to work on mine, but I know that it was a lot of typing. And so, here we go. Animals written to file, animals read from file, and these were the three pieces of data that were in the file. Fido the Doberman dog, Goofy the Great Dane dog, and Harvey the hamster rodent. So I could scroll up and down through the code, but I'm just going to put all of this stuff in the notes. So check the notes for November 28, and you'll find the entire program there. And then you can compare it to your own or whatever and spot your errors. That's not very good for the people who might watch this in future semesters. So, alrighty, we'll do a quick run through.
Okay, I'm having an error and I'm not quite sure what I'm missing.
Alright guys, so our animal class looked like this. Public class animal implement serializable. I'm sure you have all those right if you got to the first, halfway through it. Our 4 member variables, we had a custom constructor that looked like that. And we had a default constructor that looked like that. And we had a toString method that looked like that. And then we have getters and setters. Going back to ObjectOI demo, our main code, not the methods that we added to it, look like this. Scroll way down here. ArrayList, AnimalList is equal to new ArrayList animals. Then we created 3 animals. We added them to our array list. We set our file name variable and we called WriteAnimals to file, file name, AnimalList. If the write was okay, great. We printed out a yay message. Else we print out a boo message and we return. And then from here, ArrayList animals, new animals equals new, read animals from file name, and if it succeeds, we know it succeeds because new animals is not equal to null. Then we print out a happy message, animals read from file, and then a for loop. Now what I didn't show is opening the file for appending and then adding, a new object to it over and over. Or opening the file for reading and then reading successive objects rather than storing them in an array list. So I hope you can get that idea, though, of what we're doing here. And if you need to do that, if you need to open a file for appending and write an object out, or open a file, and then read a whole series of successive objects out, you should be able to find code that does that. And Google it up. Probably take you to Stack Overflow. Look in your book. You can figure it out. Okay, now for the methods. This was the end of our if code, right? But it's not the end of our method. I need to delete some white space, and I'm going to put a comment here that this is the end of main. An easy error to make is to have added these methods before get your curly braces wrong. And so here's the ReadAnimals function. It's kind of long, so I'm not going to even read it to you. You can just look at it and pause. That's the end of it. Then the next method, write animals to file. Again, I'm not going to read it out loud. Our three exceptions. I return false. This is the end of our method. Write animals to file method. And this is the end of our class. Alright, hope that was educational. I will post the source code out there anyways. I just know that if you're watching this video without access to the class materials, then you won't have it. Alright, so I'll see y'all next time. Adrian had to leave early.